3B, putting numbers in perspective. In 3B, we are going to focus on how to write large and small numbers. And we use something called scientific notation to write numbers that are either very big or very small. When we convert a number into scientific notation, first, some key things about scientific notation. The numbers that you see down here, these are examples of scientific notation. You'll notice there is only one digit before the decimal place. In this case, it's either 3 or 4. These numbers has to be between 1 and 10. Well, you can only have 9 point something. And any other digit that we have that comes after, we will represent it as a decimal place. So the 250 million that comes after is going to be represented as 0.25. In order to change from a decimal form to a scientific notation, the easiest thing to think about is to think about moving the decimal place. So for a regular number, our decimal place starts at the end over here. And what we want to do, the goal is to move the decimal place to come after the 3. So we're going to count how many places we would move the decimal point. In this case, we move 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 different places. So in this case, it's 10 to the power of 9 as my exponent. Now, when I move my decimal place to the left, that means we have a positive exponent. You can do it like this, or personally, I like to think about a number that's bigger than 1, a number that doesn't start with 0 point something, will have a positive exponent. In this second example on the right, we want the decimal place to come after the 4. So we want to move the decimal place from where it originally is, and we'll move it 1, 2, 3, 4, 5, 6, 7 different places. Because the number is smaller than 1, it starts with 0 point something. And because we move the decimal place to the right, this is a negative exponent with -7. Now, when we go backwards, we do the same thing. As before, only this time we will try to fill the empty spaces with zeros. So you notice if I start with 3.25 times 10 to the 9 over here, what we're going to do, if I need to change it back into the decimal form, I will take my 3.25. I'll move my decimal place 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 decimal places. And all these empty spots, we're going to fill them up with 0. We're going to fill them up with 0 like this. We will do the same thing with the example on the right. We take our 4, and in this case, we want to move the decimal place to the other side. So I might not have enough space here. Let's erase it. So we're going to move it 7 decimal places. So 1, 2, 3, 4, 5, 6, 7. So this is where our decimal place is going to be. Now, there's a little bit of, there's one thing that's slightly tricky. If I have a number that's less than 1, we don't normally just put a decimal and we put 0. We normally will write 0 point something. So in this case, we'll have to put a 0 at the beginning of the decimal place. You'll notice when I have a number that's less than 1, it turns out that it works out really well that the 7 over here is the number of zeros that we have. And it will always work like that. However, with a number that's bigger than 1, the 9 over here is not going to be the number of zeros. And the reason is because here we might have some decimal numbers that interfere with it. But when I have a 4, like let's say I could have a 4.1, the 1 over here doesn't really interfere with the number of zeros that we are. So that's why the number of 0 over here, in the case of a number that's less than 1, is always equal to my exponent over here. Next, we have to multiply or divide using the scientific notation. Now, there are different ways to do it. When you do this on your test, you will be able to use your calculator. So it is a lot easier for you to find the button on your calculator that shows you how to do the exponents in the scientific notation. Usually, scientific calculator comes with a button that tells you how to do that. And in my calculator, in the Windows calculator, it's the EXP button. In some other calculator, you might have a button that says multiply 10 to the power of x as a button. And in some calculator, you might have a button that says EE on. Both of these buttons are quite common, although in this case, in the Windows calculator, we have the EXP button. All we're going to do is we're going to press 6, and then everything over here multiplied by 10 to the power of is simplified by one of these buttons over here. So I simply press dot, and usually your calculator will show you sort of a way for them to sort of write the scientific notation. In this case, I only have to put the 2. You'll notice I only press 3 buttons: 6, the scientific notation button, 2. And I need to multiply by the next number, 4, scientific notation, 5. And that gives me the answer of 240 million. Now you'll notice in some calculators, if I press 6, scientific notation 2, like that, it actually, oops, not like that. It actually changes the scientific notation into a decimal form for us. So that can be convenient for you when you do your questions. Now, let's say you don't have your calculator. What you have to do is you have to multiply the numbers in the front separately from the exponents of 10. When you multiply the exponents of 10, add up the exponent. So that becomes an exponent of 7. So I have 24 times 10 to the power 7. But because we don't have a number we don't have a number of 24 at the beginning of the scientific notation, we can only have a number between 1 and 10. I had to divide the 24 by 10. And when I divide it by 10 here, I have to multiply the second part by 10. So I separate the 24, and you can think of it as writing the 24 in scientific notation. And then we combine the exponent again. When we divide, same idea, but when we divide the power of 10s, when we divide the exponents, we subtract them. So you'll notice in this case, I have 4.2 divided by 8.4, 10 to the negative 2 divided by 10 to the negative 5. And what I will do is I'll subtract them. I'll do negative 2, subtract the power, minus negative 5. And that will give me 10 to the power of 3, positive 3. And you notice when I divide over here, I get 0.5. The easiest thing to do, write it as a scientific notation. And now we're multiplying the exponents. We can add up the number to get to power of 2. Now, most of the time when we do these type of questions, you will just use your calculator. So you will just use the calculator. And on the test, you'll be able to use your calculator as well. So here we're going to press the exponent. Now, some calculator lets you put the negative sign first. Some calculator require you to put the negative sign second. So here I can put the negative sign, negative power of 2, and I divide it by 8.4, and I do this button, and then 5, and negative. So we get 500, the same. Now, I just want to point out, if you decide to type everything out in a long way, remember to put in the brackets, because it's really easy. You have to put a bracket around all your scientific notation if you don't use the scientific notation exponent button. So if you want to put 4.2 and you want to actually type out 10 times 110 to the power, the power button is over here, -2. Then you need to keep the number in a bracket in order for you to get the right result. The reason is because when you're doing division over here, if you don't put a bracket, what your calculator will do is your calculator will only divide it by 8.4, but it won't divide it by the second part. Whereas if you use the scientific notation button, there's not a problem of that. So you notice you can also do this, and it'll give you the same answer. However, if you don't use the bracket over here, you're not going to have the same answer. So here we're going to go through a few examples of how to get some perspectives on the numbers. So let's say Canadian government debt, there's all levels of Canadian government owes a total of about $3 trillion. $3 trillion is a little bit hard to understand, right? For us, it's 3 with a whole bunch of zeros. But let's put it into some perspective. Let's think about approximately 40 million people in Canada. So how much is it per person? So I can take $3 trillion divided by 40 million people, and we can find that it's roughly $75,000 per person. Wow, that's a lot of money that the government owes for us. So if you become a Canadian, the day you become a Canadian, you owe $75,000. Well, the government owes $75,000 for you per person already. And sometimes, this is sort of what we do when we only calculate numbers, not the exact number, but the order of magnitude. Like when we say 40 million people, it's not exactly 40 million, right? It's probably 37 million and a few 100,000. I don't know what the exact number is, but a lot of times it's easiest for us to just put a whole bunch of zeros at the end for us to get an idea of how big the number is. Another way is to make comparisons. So for example, Canada's GDP is 1.643 trillion. The world GDP is 84.71 trillion. And we have about less than 0.5% of the world's population. So how do we put these numbers? How do we compare these numbers together? Well, notice how here we're comparing the population, right? Canada, the population of Canada is about 0.5% of the world. We can do the same thing with our GDP. 1.643 trillion divided by 84.71 trillion, that's 0.0193 roughly, or 1.93%. Hey, that's pretty good. We don't take up that big of a share of a population, but we take up a bigger share in the GDP. So Canadians produces above average goods and services. So that means we are kind of a little bit more productive in the economic sense. It doesn't mean that we're working harder. It just means the stuff that we make is worth a little bit more on the global market. Finally, we do something called scaling. And we do this, we do scaling when you look at maps, when you look at models, when things are shrunk or made bigger. And we can describe scale as either through verbally and say the 1 centimeter here is the same as 1 kilometer, or we can have a picture over here on the map, and on the map over here, we will have a line, and the line is say 200 meters. Or we can do a ratio, and often we're given a scale ratio, and what that means is, in this case, the map to actual distance is 1 to 100,000. So if I have 100,000 meters in real life, I shrink it down to 1 meter on the map. So we can do this we can build a scale of the solar system if we want. So for example, if we're trying to build a model with a scale ratio of 1 to 1 billion, what we'll do is we're saying that the real distance divided by 1 billion is what I'm going to draw on my map or build on my model. What we'll do is I'll take each of these distances and I'll divide it by 100 billion. 150 million kilometers divided by 100 billion is 0.0015 kilometers, or 1.5 meters. The diameter of the sun, I divided by 100 billion. It's a very small number. And for now, I'll just tell you that it's 1.4 centimeters. And I could do the same thing with the size of the Earth, the diameter of the Earth, and it's really, really small, 0.1276 millimeters. And if you think about building this at home, the scale, the 1.5 meters, that's roughly from head to toe, right? Depending on whether you're a tall person or a short person, but probably not all the way to your toe for most people. And how big is the sun? The sun is, has a diameter of 1.4 centimeters. That's sort of like the size of your pupil, or the size of your iris, like of your eyes. And how small is the Earth? Well, the Earth is 0.1 millimeters wide. That's really, really small. That's like probably the thickness of a few sheets of paper. So you can see that Earth and Sun are really far away, but the actual size of Earth and Sun are really small.